Hello friends, welcome to Dr. Acharya Academy. Today I'll discuss on the CBSE syllabus the chemistry for class 11. This class is based on the NCERT books. So today the topic is the properties of matter and their measurements. Today's class ID is 003. As I told that CBSECH11, CBSE for the syllabus and CH denote for the chemistry and 11 means class 11. So start with the physical properties now. Every substance has unique or characteristics properties that we know. These properties can be classified into two categories. Number one, physical properties. That means color, odor, melting point, boiling point, density, etc. And another property is its chemical properties. That means composition, combustibility, reactivity with acid and bases, oxidation reduction, etc. Physical properties can be measured or observed without changing the identity or the composition of the substance. So you have to remember here that physical properties we can measure without changing the identity or composition of the substance. That means for the measurement of the physical properties, no need to change the identity or composition of the substance. But the measurement of the chemical properties requires a chemical change to occur. There is a difference, another difference for the physical properties and the chemical properties during their measurement. So the chemical properties are characteristics of reactions of different substances. These include acidity, basicity, oxidation reduction, combustibility, already I told. So these characteristics reaction is the chemical properties. It is a general statement that chemists describe, interpret and predict the behavior of the substance on the basis of the knowledge of their physical and chemical properties. That means if chemists want to interpret any behavior of the substance, then both physical and chemical properties is required, and which will get by the measurement and experimentation. Now, measurement of physical properties. Many properties of matter such as length, area, volume, etc. are quantitative in nature. Any quantitative observation or measurement is represented by a number followed by units in which it is measured. That means that measurement will have one number, and after that one unit needs to add. As for example, if you see, if I consider my reading table, then its length can be represented by 2 meters. So here 2 is one numerical number and m is an unit. M denotes in meter. This unit in which the length is measured, and 2 is the number. There are some system developed. So two different systems of measurement, that means one English systems and one metric systems, are used in different parts of the world. The metric system, which originated in France in the late 18th century, was more convenient as it was based on the decimal system. That means metric systems is based on the decimal system. Need of a common standard system was filled by the scientific community. Now we will discuss about the SI system, International System of Units. Why the name is SI? SI, this abbreviation has come from International unit. From there it has come, the system is for S and international for the I. So this abbreviation SI comes from there. And it is established in the 11th General Conference on Weights and Measures. And it was signed at the year 1875. The SI system has 7 base units. These units pertain to 7 fundamental scientific quantities. Number 1, length. Number 2, mass. Number 3, time. Number 4, electric current. Number 5, thermodynamic temperature. Number 6, amount of substance. And number 7, luminous intensity. So these all has the symbol for the SI unit. So we'll discuss one by one now. The other physical quantities of speed, volume, density, etc. can be derived from these quantities. Now, definition of SI base units. Unit of length is meter, and the definition is, it is symbolized by small m, and it is the SI unit of length, is defined by taking the fixed numerical values of the speed of the light in vacuum, speed of the light c, to be 299792458, and it is expressed by the unit m by s, ms to the power minus 1, where the second is defined, second, that means the small s, defined in terms of the cesium frequency. Now, unit of mass, which is in kilogram. Unit of mass is kilogram as per SI system. This is symbol is small k, small g. And it is defined by taking the fixed numerical value of the Planck constant h. Planck constant is h. And Planck constant's value is this 6.62607015 multiplied by 10 to the power minus 34, and its unit is capital J small s, and which is again, this unit is equal to as per the base unit kg m square s to the power minus 1, where the meter and second are defined in terms of speed of light, whatever we discussed, and the frequency of cesium. Now, unit of time. Unit of time symbol is small s as per SI system, and it is defined by taking the fixed numerical value of cesium frequency, the unperturbed ground state hyperfine transition frequency of the cesium 133 atom, and it is 919263170, and its unit is Hertz, Hz, capital H, small z, and which is equal to S superscript minus 1. Now, unit of electric current, which is ampere, and this ampere is symbolized by capital A as per the SI system. It is defined by taking the fixed numerical value of the elementary charge E, small e, to be 1.6021766634 multiplied by 10 to the power minus 19, and when expressed in the unit capital C, which is equal to AS, where the second is defined in terms of, again, the cesium frequency of the cesium, whatever we discussed above. Now, unit of thermodynamic temperature, which is Kelvin. So, Kelvin is symbolized by capital K as per SI system, and it is defined by taking the fixed numerical values of the Boltzmann constant, small k, to be 1.3800649 multiplied by 10 to the power 23, and its unit is capital J, capital K to the power minus 1. This capital K is the thermodynamic temperature, unit of the thermodynamic temperature. Small k is the Boltzmann constant. So now we'll know that what is capital K and what is the small k. And again, this jk to the minus 1, it can be defined by the base units kg m square s to the minus 2 k to the minus 1, where the kilogram, meter and second is defined by AC and frequency of the cesium, as we discussed earlier. Now, the unit amount of substance is mole. So that mole symbol is MOL, small m, small o, small l, as per the SI system, to describe the amount of the substance. 1 mole contains exactly 6.022140076 multiplied by 10 to the power 23 elementary entities. So this number is the Avogadro constant, Na, capital N subscript capital A, and when expressed in the unit mole to the power minus 1, and then it is called the Avogadro number. The amount of the substance, which is symbolized by a small n of a system, is a measure of the number of the specified elementary entities. An elementary entities may be an atom, a molecule, an ion, an electron, any other particle or specified groups of particles. Now the unit of luminous intensity, which is the candela. The candela, which symbol is the CD, small c, small d, CD, and is the SI unit of the luminous intensity in a given direction. It is defined by taking the fixed numerical value of the luminous efficacy, which is CD, capital K, subscript small c, small d, and the fixed numerical value of the luminous efficacy of the monochromatic radiation of frequency 540 multiplied by 10 to the power 12 Hz to be 683, and its unit will be the Lm dot W, capital W to the power minus 1, and which is again this unit is equal to the CD dot SR dot W to the power minus 1. This SR is the SI unit, steradian or square radian of a solid angle. We have to remember this much only, and again another unit will be the CD SR kg to the power minus 1, m to the power minus 2, s to the power 3. And this kg, that means kilogram, m means meter, and s means second. Already we defined it previously by the h, c, and frequency of the cesium. Now, some prefixes we used for the SI system. This is one table, just to remember some point. 10 to the power minus 24 symbolized by the small y, and similarly 10 to the minus 21, 10 to the minus 18 is the auto, which symbolized by small a. 10 to the power minus 15 is femto, 10 to the minus 12 is pico, 10 to the power minus 9 is nano, 10 to the minus 6 is micro, 10 to the minus 3 is milli, 10 to the power minus 2 is centi, 10 to the minus 1 is deci. Similarly, this will go down 10, 10 to the power 2, 10 to the power 3, 10 to the power 3 is kilo, 10 to the power 6 is mega, 10 to the power 9 is giga, 10 to the power 12 is tera, 10 to the power 15 is penta. In this way, it will go up to 10 to the power 24.